I've got the first problem, the distance from that point to the line worked out here. There were a lot of steps, so one of the things that's really important, I think, is just labeling your work. So notice I started by calculating QP. So that gave me the vector 0, negative 6, 5. Then I wanted to calculate this vector here that was my projection. So I wrote out my formula for the projection and calculated that out. Okay. I will point out that I got a multiple of V. And I did that scalar multiplication. I did that because I knew I was going to need to do the subtraction. And anytime you're subtracting a vector, you really need to know its components. It's not useful to keep it in this form. But I mention that because in the next problem, when we have a projection, we just need to know its magnitude. It's actually going to be simpler to keep it in this form of a scalar multiple of another vector. So I always think about, do I want to do the scalar multiplication? Does it make my next calculation simpler or harder? Okay. Then I did the subtraction. Okay. Now when I did that, I got a vector that had 3 fractional components with different denominators. I just rewrote this one with a denominator of 6, and that allowed me to factor out 1/6, so that instead of having 3 fractions to work with, I could say I've got 1/6 of this vector that has no fractions in it. And then the magnitude of that vector is just the absolute value of that scalar 1/6, which of course is 1/6 because it's positive, and then the magnitude of that vector. So that I didn't have to work with squaring a bunch of fractions, I could just square a bunch of whole numbers. So my final result was the square root of 2190 over 6. What I'm going to do is just leave this up and stop talking for a little bit so that you can check your work if you had worked this out on your own, which I hope you did.